Welcome to the solution video for the Searching for Data challenge. Let's open up Visual Studio and create a new project. We're going to create a Windows Form app project, so still .NET Framework. Since the .NET Core 3.0 is not officially released yet, we're going to go with the .NET Framework version. Going forward, if you can, move the .NET Core, but in this case, we can't quite yet. We're going to call this the Searching for Data, and we're going to say Searching for Data app is the solution name. And it's .NET Framework 4.7.2. That's fine. That'll work. And we hit Create. Now again, let's shrink this form down first, because it's going to grow once we change the font size. But first, we're going to change this to say, I usually go with dashboard if I don't know what to call it, just to make sure that I have something other than Form 1. Form 1 is awful. I don't like to do that ever. Okay, we'll call this the Searching for Data Solution by Tim Corey. That's going to show up in the title bar. And now we can change that default font from the horrifically small 8 point to something like 18 point. And now that it resized that form, but since I had scrunched it so tiny, it's a little bigger, or a little bit more manageable now. And I think that's all we're going to do at this point. We can hit save. And now we can drag on some controls. Let's go to Toolbox. Common controls. And by the way, you can do this with WPF if you wanted to, or even one of the web frameworks like ASP.NET Core or ASP.NET MVC or whatever you want to do. But this is just quick and easy to do it this way. So I'm going to say a label first, and then I'm going to have a let's rename the label first. I always get ahead of myself if I'm not careful. So let's call this the text to search for label. And just say search for, like so. That way we know how large this is to put our text box next to. We can make this bigger. This is called the text to search for label. I'm going to copy that actually since it's a little long. I want to get it right. I'm going to paste it in, but take off label and put text. So that's the text to search for. Now we need some way of displaying that text. I think what I'm going to do is just put a list box here, and then I'll put a label on top of it. So make the list box fairly large. I think that's probably good. And I will copy and paste. I am getting a little ahead of myself. I haven't renamed the list box yet. So let's rename both of these. This is going to be the results label. And this is the results list box. This is results. Okay. It's going to find every line that has a match, and then it's going to put the results in this list. Now, if you haven't already looked at the primary.txt, this is what it looks like. notice that I turned word wrap off. There's word wrap, doesn't matter, because I actually put line breaks in here just so we didn't have like 6 lines. To a few more lines than that, because otherwise a paragraph is just one line. So I broke the paragraphs apart into multiple lines. So this is the from the C# Wikipedia, and it's just basically I needed some kind of text, so I grabbed the Wikipedia entry for C# and it's copied the large chunks into this text file. That's why we have all these references here, which of course I don't have the references down below, and we have some other detritus that we probably should clean up, but it's not a big deal. We're just using this for something to test searching on. But if we look, there's language and evaluated, and there's language again. I think language might be a good one to search for because it's used in here quite a bit. I'm just not sure if it's used too much. So we'll have to try out different things, but that's a good one to start searching for. So when we go into the search button text, I'm going to put all my code in the code behind. I try to say this every time, but just note that this is a test app just to teach us how to search for text inside of a text file. This is not about making a real application or complete application. Otherwise, I'd have a class library doing the actual work, not my code behind. Okay, that's my disclaimer. We can move on now. So in here in the search button or search text button, what's going to happen is it's going to take that text and it's going to search my text file. So first we need to bring in, I believe it's system.io. So using system.io, which will allow us to open a file up. So we can say, I believe it's list of string we can do, and say lines equals file dot, is it read all lines? There we go. Read all lines of, we're going to hard code this, temp, and it is primary.txt. Of course, your path will vary. And then at the end of this, to list. That should work. So now we have all the lines of the text file into this list. We're going to refactor this in a minute, but that'll work for now. And now we can do is we can take our search text and create a new list. In fact, let's make this list live out here. List. I'm debating between binding list and a list. Let's do binding list. Binding list of string matched lines equals new binding list. And then every time we add something to match lines, then we will, it should tell the combo box, hey, it's been updated, or list box, it's been updated. So this is the results list box dot data source equals matched lines. So now whenever we add to this list, it should say, hey, there's a new entry, display that. Also at the beginning of this, we'll say matched lines.clear just to start off with an empty list since we're going through this file again. Otherwise, we'd have duplicate lines. For each line in lines, we're going to say if line dot contains, and see whether or not it contains this string, which is going to be the search. I'm not sure I named it. It's called text to search for. Text to search for text dot text. If it contains that text, then we're going to say matched lines dot add line, like so. And that should be all we need to do. Let's run this and see if it works and see if it matches what we expect. So language was 1. Click search. Notice we have a whole bunch of entries in here that all have language somewhere in them. Now, we've got to figure out, is this all of them? And that's a tricky one. So let's do this. I see Delphi here. Let's look in our file. Let's also make this a lot wider. We have the screen real estate. Let's make it wider so we can read more of that text. And then we're going to look in our primary file and let's do a search for Delphi. And it says I can't find it going up. Let's go down. 1, 2, but in the same line. 3, same line. A second line, and that's it. So it should have 2 lines come back if we say Delphi. The other thing we haven't checked is see if we have case sensitive. So let's do Delphi, which we know they're all uppercase D's. Click search, nothing happens. If I click capital D, I get 2 entries back. So we know now that we're doing a case sensitive search. So let's close this out. Go back. It's going to be zero-based index of first occurrence. So as long as it is 0 or above, it's found that text somewhere. So we're going to say greater than or equal to 0, the index of this. But that's still case sensitive unless we look at one of the overloads, which is, and that went off a screen, sorry, comparison type. So we can say string comparison dot, and we have a few options here. And one of them is ordinal ignore case, which uses the binary sort rules and ignores the case of the string being compared. So doing that, it should be that now if it finds that text right here, if it finds that text in the line, if it finds a position for it that's 0 or greater, meaning it's found something and here's the position at the start of that, then it's found it, therefore it contains it in that line. Otherwise, it's going to return -1, meaning I couldn't find an index of it anywhere, and we'll ignore it and will not add to the line. Let's try this. All right, so we're searching for Delphi. We hit search, and we find these 2 lines, even though we search for lowercase Delphi. Notice also if we search for Delp, it still finds it. If we search for DE, finds a lot more. So it is doing a search. It is finding the different matches based upon even a part of a string, not the whole string. And it's now case insensitive. So there is the primary challenge complete. Now the secondary challenge, we're going to look through a different file and we're going to just display the phone numbers. We're not going to ask the user for anything. So I'm going to I'm going to copy this button actually and paste it over here. This is not terribly awesome UI design, but it'll work. I'm going to go to properties here and say search for phone numbers button. It's a long name. And we'll say phone number search. And make that larger since we have the room, why not? So this button right here, what it's going to do is it's going to allow us to search for phone numbers in a different text file, which is actually pretty much the same text file just with phone numbers added. And we're going to put the results in this same list box. So let's double click here. And this is the search that we're going to do. So we can say, same basic premise, is we're going to say string instead of list of string. We're going to say file text, not PHILE. File text equals file dot read all text. Not read all lines, read all text. What that'll do is just put everything in one big string. And then the path to add the using statement for system.text.regularExpressions. And we're going to call this just regex is fine, equals new regular expression. And here's where we build our statement. I'm going to use the @ symbol first to say ignore escape characters, because even though there are escape characters in here, it's regular expression escape characters, not standard C# string escapes. So that's where the first thing gets a little tricky. Now, how am I going to match these phone numbers? Let's look at a phone number real quick. A phone number in the US, we're not going to assume a country code. I'm trying to keep this as simple and easy for you as possible. A phone number starts with an open paren and then 3 numbers. Let's just say 1, 2, 3. Close paren, space, then 3 numbers, then a dash, then 4 numbers. Okay, so that's the pattern. This pattern right here is what we're looking for. But I did say to make sure there's a space on each side, because if you have this big text file and you had a phone number, but it was maybe like that, that wouldn't be a valid phone number, because now you're not quite sure, is this a phone number or is this the information and then this is something else, or maybe it is a ID number now instead. The other possibility is if we had this, again, not a phone number, because even though this matches a phone number, the fact that it has all these numbers compressed together means it's probably more of an ID number or something else that kind of looks like a phone number. So I said make sure there's a space on each side of our phone number. So we're going to start our regular expression with a space at the beginning and a space at the end. And if it doesn't match that, it's going to say this is not a match. Next, we're going to put an open paren, but we have to escape it. So escape, and then open paren. Notice this. Let's see if I can come back. This is something new in Visual Studio. They actually have help for our regular expressions, kind of telling us what the different parts of a regular expression are. That's kind of helpful. In this case, I'm going to escape a paren. So we have a paren, and then we have another paren, and this one is a define that there's a sub-expression. So in here, we're going to say in square brackets, anything from 0 to 9. Now I could say digit, but I think this makes it a little bit more readable. Anything from 0 to 9, and I want, in curly braces, 3 of them. And then I have my close paren, and then from there I have my escape character, and I have close paren. So essentially that's looking for this piece right here. Now we've got our space we're looking for first, that's right here. Then we're looking for an open paren right there. And then we're looking for 0 to 9, one of those numbers, we want exactly 3 of them, which would be like that. And then we're looking for a closed paren that's right here. So that's our first. Where we're looking for 0-9. And we're going to do 4 of those and close our sub-expression. So we have our 4 numbers at the end. We have our dash and the 4 numbers, and then make sure that space is at the end. Somehow that got eaten up. So that is our regular expression. Okay? If you take it little chunks at a time, not that hard to understand, but when you look at it as a whole, even now my eyes glaze over because that's confusing. Okay? But again, little sub-expressions, and that's the big takeaway from regex. Create sub-expressions and build them up if you can. That's what we're doing here is sub-expression, sub-expression, and sub-expression. And then just looking for the dash, the space, the closed paren, the open paren, and the space. Okay? So now that's going to match exactly this. Okay, with a space on each side. So now we have our regular expression. What we can do is say match collection. We'll call it matches equals regex dot matches, and it's matches found in the file text. So it's going to use our regular expression and look for matches in this file text, the text file bonus.txt. So now we can do is do a for each and say for each match in matches. So we're going to loop through every single match that we found and say if match, and then we have, interesting, it's saying that it doesn't know what match brings or match collection brings back, so we actually have to tell it match. There we go. So now it's going to say it has a bunch of different things in here, if it's successful or not, and what the next match is. We have this thing called groups here, and a collection of groups matched by the regular expression. And we'll look at that in just a minute, but let's just do groups. We're going to do the first one, because that's the actual match, and we're going to say value. So if the value, and we're going to do I'll wrap this, I'm going to control X it for a minute, string.is null or white space. I always do this. I always forget to do that first before I put in my text to compare. So as long as this is greater than 0, meaning it has some kind of matching text in there, then what we're going to do is we're going to say matched lines dot add, and we're going to add this value. And that's going to add the matching phone number. So let's run this. I'm going to put a breakpoint right here. We're going to start this up. By the way, we should look at the text file before I go too far. Same text file pretty much, except that I inserted some phone number like items. But notice, like this one, it's got the dots between them and no parens. This one looks right, except there's no space between created and the start of it. But then this one right here is perfect. And there's more down here. There's more hidden in this system. Some are good, and then some are not. Like this one looks great, except there's no space between the closed paren and the 9. Now, when you're searching through for phone numbers, maybe you don't want to be quite so exacting. It depends on your requirements. Maybe you say that space is optional depending on your data, because data is not always perfect. Okay? Let's come over here and do a phone number search. And now we have our matches. And if we look at matches, I believe we can get a count. Yep, right here is 4. So you have 4 matches in our text file. And if we look at the groups, so we have match.groups, and the group count is, it says it's 4. So match.groups, we're going to pull the first one out, which is that 212. And if we go again, now it's the 818. We go again, now it's a 404. And finally, it's the 998. So now with that done, it shows nothing in our box. So let's find out why, because it should. Let's do it again. And let's find my now hidden thing. And there we go. So is null or, I said is null or white space. I meant equals false. So if it's not null or white space, let's try that again. So doing this and saying phone number match gives us 4 phone numbers. We should probably trim those since we've got that leading space. So let's do that. Value, and we're going to trim. And that just takes the trailing and leading spaces off. And now there's the 4 phone numbers in that text file. And just doing a quick count verifies that yes, in fact, there are just 4 phone numbers in that list. Now, if we took off that space requirement, where we didn't have to have that space at the beginning and the end, and we did a search, we'll find that we have 6. So it all depends on if you want to, again, open up those parameters or not. But our requirement said to do an exact match on the format and make sure there's a leading and trailing space. With that being said, I think we're done. And technically, we're done with the bonus challenge as well. But I did want to point out one thing that, hey, maybe it'll make your life a little easier. And as long as you don't have a super huge text file, this would work. If we moved this right here, this line, and moved it out to here, then what we could do is we could change this. Instead of clicking the search text button, we could actually go to this text box, and under events, we could add a text changed. And then here we could say if text I hooked up the wrong search button or search event. There we go. Much better. Let's try this again. Nope. Oh my goodness. Tim's going too fast and causing problems. There we go. So now, if I were to search for Microsoft, notice how it filters down. And I search for Microsoft that. Well, Microsoft that. I just looked for that right there. But I can do a search now dynamically for anything I want without having to hit the search button. So it's possible. Just be sure you're looking at the performance requirements for your application and making sure that the memory is not an issue, because if it gets to be too big a file, that might take too long and you might want to wait for the user. There's also a thing called debouncing, where you essentially wait for the user to be done typing before you start searching. So if I were to type Microsoft as fast as I could, it's doing a search on every letter. But really what you want is you want it to do a search once I take a breath, once I pause for a little bit, then you search. So that's something you might want to think about in a real application, quote unquote real application. But that's definitely a possibility for doing that search. Okay, so with that being said, we've now completed both the standard or primary challenge as well as the bonus challenge. Hopefully you got this. Hopefully you were tracking along. Maybe you had a couple things different in your application, but hopefully you learned something from that. Either way, thanks for watching. And as always, I am Tim Corey.